Welcome to today's video. Today we're focusing on solving systems of equations by elimination, but today we're going to use multiplication. We're going to show that mastery in class tomorrow by scoring at least an 80% on an exit ticket. Hopefully you have the note sheet in front of you. If you don't, make sure you have a separate sheet of paper that you can take notes on, and we will go back tomorrow in class and give you a brand new one. Now, similar to yesterday's lesson where we were solving using elimination with add and subtract, we still want our equations in standard form. However, this time we're going to have to multiply or divide one or both, depending on the situation, by a constant, so at least we can get one pair of terms to have opposite coefficients and be able to eliminate or cancel out. Then we're still going to follow the steps. Once we can cancel out one of our terms, then we're going to solve for one variable, substitute it back in, and get our coordinate point for our answer. Now, example 1 is a review from yesterday. We have two equations that are in standard form. If I look, my x's are not opposites, but my y's are opposites. So in this case, my y's are going to cancel out, and I'm going to be left with 2x is equal to 4. Well, if I solve for x, I'm going to divide by 2, and x is equal to 2. From here, I'm going to plug it back in. X plus y equals 3. Well, x is 2 plus y. We're going to subtract 2 on both sides, and now I'm left with y is equal to 1. So my final answer would be 2, 1. Now, if we look at example 2, I have x plus y equals -9, and 5x minus 2y is equal to 32. If I look at both my x's and my y's, I don't have any terms with opposite coefficients. So what I'm going to do is I'm going to have to pick an equation and multiply. Now, if I look at my x values, I have positive 5. Well, if I need the opposite, that would be negative 5. So if I have 1x, I'm going to multiply everything in this top equation by negative 5. That leaves me negative 5x minus 5y is equal to positive 45. Well, from here, now I have two terms that are opposites. My x's are opposites of each other, so they're going to eliminate, and I'm left with negative 7y equals 77. If I want y by itself, I'm going to divide both sides by negative 7, and I'm going to get y equals negative 11. Now, from here, to be able to solve for x, you have to pick an equation. You can choose either your original equation, the one you got when you multiplied, or your second equation. I'm going to take the original of x plus y equals -9. In my eyes, that's the easiest equation to use, but you can use any of the three. I'm going to say x plus -11 is equal to -9. I can also rewrite this as x minus 11 equals -9. Well, I'm going to add 11 on both sides, and I'm going to get x is equal to positive 2. So that makes my coordinate point 2, -11. If you use any of the other equations, whether it be the 5x minus 2y or the negative 5x minus 5y, you will still get an answer of x equals 2 out. So it does not matter which equation you choose. If we look at example 3, both of my equations are in standard form. I have 2x plus y equals 3 and negative 4x minus 4y equals -8. In order to get something to cancel, I need opposite terms. I'm going to multiply my top equation by 2 because now I'm going to get 4x plus 2y equals 6. Well, 4x and negative 4x cancel each other out. You could have also multiplied the top by 4. That would get your y's to cancel, and that's perfectly okay too. I like to start with the x's because it comes first in the equation, so I'm going to cancel what comes first. From here, I now have negative 2y equals -2. Well, if I divide on both sides by -2, I get an answer of y is equal to 1. From here, we need to plug it back in. And again, it doesn't matter which of the three equations you use. I'm going to use the first one, 2x plus y equals 3. Well, y is equal to 1. And substituting it back in, I'm now going to subtract 1 on both sides. 2x equals 2. Well, dividing by 2 gives me x is equal to 1. So my final answer is 1, 1. Now, if we look at example 4, we're in standard form, and I have 2x minus 3y equals 21, and 5x minus 2y equals 25. If I look at both my x's and my y's, there's nothing pretty as a whole number or an integer that I can multiply one or the other by to get opposite terms. So in this case, we're going to end up multiplying both equations. I'm going to take my top equation, and I'm going to multiply it times 5. And the reason I chose 5 is because that's the coefficient of x in my second equation. So if I do that, I get 10x minus 15y equals 105. Now, here's the part you have to be careful. If I want opposite coefficients, that means I need a negative 10x in the bottom. I have a positive 5, so in this case, I'm going to multiply it by negative 2. Not just positive 2 because it's the other coefficient, but I need those opposite terms. So if I multiply by negative 2, I get my negative 10x. Negative 2 and negative 2 give me positive 4y, and then negative 50. From here, now I have my terms that cancel, and I'm left with negative 11y equals 55. Well, I'm going to divide both sides by negative 11, and I get y is equal to negative 5. Now from here, it does not matter which of the 4 equations in this case that you can choose from. I'm going to do 2x minus 3y equals 21. Well, we know y is negative 5, and negative 3 and negative 5 give me a positive 15 when multiplied. So then I'm going to subtract 15 on both sides. I'm left with 2x equals 6, and dividing by 2 gives me x is equal to 3, leaving my final answer as 3, negative 5. Please make sure when you're multiplying, the big thing you have to focus on is you want opposite coefficients for the same terms. So if you're focusing on the x's, you need opposite coefficients on the x's. If you're trying to eliminate the y's, you need opposite coefficients on the y's. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.